So I wasn't going to stream today, but I decided to spend some time studying because I already knew, but the course that I made, not made, that I took was only one module out of four modules of how to build a compiler. And I found the other website, the other modules, but the price is too high. So like I recommend taking the course. It's from this guy here on Udemy. It's the first module because it's very cheap and very useful. I really liked the course, but this one is like very expensive. I'm not gonna pay $300 to do the other modules. So what I thought about doing is just going over the modules here and seeing if I can find any keywords. And then today I'm just gonna spend some time. I think I'm gonna spend 1 hour and a half studying this. I'm gonna look over the source code, and then I'm gonna research some keywords and see if I can find other resources on YouTube. And I'm gonna try to find other courses on Udemy as well, which I already did a little bit of research, so I think it's not gonna be possible on on Udemy courses about the code generator part, which is the part that I'm interested on. So I want to understand more the ISA, however you say that, hardware instruction set architecture, and I want to clarify the gap between creating the compiler and how the actual hardware is going to execute the instructions. So that's what I'm going to be doing. And then after, I'm already started watching the thing again, the course, but I'm still on the very beginning again. And I think this time I'm gonna take a lot more time on each thing, and I'm gonna try to follow along, so it might take me more time to finish. I think it's around 14 hours the course. You can pull it up here. Yes, 14.5 hours. So it's gonna take a lot of time. But I think in 2 days I can finish this because I'm gonna be. Last time I did it at 3x speed with a Chrome extension that allows you to modify the speed on HTML videos. So I did it, I think, at 3x or higher, and I was just more trying to understand like the whole overall structure and how he goes about doing things. Which pretty much the way that he does it is create a bunch of structs and flag variables, and then based on that he pattern matches everything. And yeah, so I didn't pay too much attention on the files and the specifics of C that I didn't understand very well, but this time I'm gonna spend a lot of time studying each thing and trying to take notes. So it's gonna take more time because I think I'm gonna go over only at 2x speed. So I think, and also I fixed all the problems, I believe, unless there's a problem that I didn't ask for on the other project. So I think I'm gonna show that. And the issue I was having is that I was setting a color for all the edges on the same object. And also I had to refresh I had to change the timeline when I changed the edge colors. So because I was using the same timeline. So first I had to figure out that I have to refresh the timeline, so set the timeline again. So it's not using the previous one. And then after that I figured out that I was using the same object for all the edges because I was initializing the object outside of the loop. And then this was making it so that on the time of the animation, the first frame of the animation, it makes all the edges have the same color, which was not what I was intending. Was just changing the color sequentially for each edge. So, but now it seems that should be working. So what I think I'm gonna do is, like I said before on the previous stream, I'm gonna copy some files. I'm not gonna do the code by myself. I'm just gonna try to copy as many things as possible, but trying to understand the logic behind the way he did, and then modify or change things in the way that I think it's gonna be better. And then as I'm going through, I'm gonna search for stuff that I don't understand about C. And I think like the header files are kind of confusing to understand, but I think that pretty much they allow you to use the same function on several different files. Because if you're using two different compilers, or if you're using functions from other projects, then there can be collision, because you can only define a function once. And the definition is when you declare the function and you put the code of what the function is going to do. So you can only define once, but you can declare multiple times. And the declaration is just a part of the function name and the arguments. And I believe that's the case because every time you define a function, it creates a signature. So the program can only have one signature for the function. And you can't have two different functions with the same name. But you can have several different declarations of the function. So you put the declaration on the header, and that allows you to use the function everywhere else. But it is kind of confusing to understand. And then you can put this if and def here, which stands for if not defined. Then you define whatever is going to happen. And I think somewhere here should have an end clause. Or in the example that I saw, he also puts an end if in the end there. Oh. No, this one looks like it doesn't have. Maybe this is in the very end, but yeah. So from the point that I saw today, he creates a file. I also realized that I have the source code for all the modules because I found on GitHub. It's public, so. But obviously the course is better because it explains everything, so I still recommend doing the course. And the Udemy course is not expensive, so I think it's definitely worth it. Most of the courses on Udemy are garbage, to be honest, but there are a few courses here and there that are very good. So it really depends on who is the person that created the course. Oh, and the make file, the way that it works, I figured out how to make it work. You just use a package manager called Chocolate, however you say that. Let me search on. And then you just type the command choco install make, and then it installs for you the make executable. And then all you have to do is just call make on the directory you want to run, and then you have to specify the make file. I think chocolate. This thing here, however you say this. Then all I have to do is just call make, and then it compiles everything for you. It calls the commands that you specify here. So the includes, I think, is the libraries that is going to include, and the objects is probably the stuff that is going to run. So each time that he creates code on the project, he has to put other stuff here specifying what you want to run, like the directories and everything. And then it allows you to run everything from the make file. It's not that complicated. I think I'm just gonna copy this build here. This part I don't know if he did there. He created the build file. Because I don't remember seeing he creating, but I do remember him putting the build file on the make file. And I think it's not that important. It's just gonna be, I think it's kind of similar to the way that Yarn works. When you run build, it just bundles everything into one thing. So the file that he starts off with is process, I think, something, C process. Yeah, this one. And I think on this one he creates the function that is going to read the file. So it accepts the file name and then file out in case you want to write. Because in the thing that he's doing, he's actually going to write stuff to other files, I think. But for me, I only want to get the file and then read the file. And then based on that, I create everything. So, but obviously here there's a lot more functions because it's after he already did everything. So it's one of these functions here. Or maybe he changed. I think it's this one, yeah. So this is another thing that is kind of confusing and I didn't remember really well, is that in C, and I think in C++ is the same thing, you declare the name, like, you declare the structure of the function. So, like in Python and JavaScript, it's all, the interpreter or compiler probably does that for you, which is, like, because in C you can overload functions, so you can have two functions with the same name but with different types. So if you can create an int version of this function, I believe, and it would allow you to do that. So you have to specify what type of function it is, I think. And I think I'm not really sure if this is the return state, like what the function is gonna return. I think it is probably. It's confused. I'm confusing this because of TypeScript. I remember in TypeScript is different, but it's similar. So I don't remember very well. And then I should probably, I think this complains because I don't have this stuff on the header file probably. It's a compile process. Also, the other thing he does and he doesn't explain is this vector file. So it's a bunch of helper functions that work with vectors, and he uses that. The other thing that I learned is you should use this, not sure what the name of the symbol is. I don't know, like arrows should define, to include libraries that are external libraries and then use the strings when it's a local library. I think I'm gonna copy the helpers and then I'm just gonna look at the functions. Maybe you should just, it's easier to copy the whole folder. Just delete this. So I guess this is one thing that I should pay attention to on the course. So what I'm gonna do is just, I think yeah, I already showed this. The other thing that was an error here is that I added another event listener for mouse leave, because the reason why it was buggy when I was dragging this around is that sometimes, I think it's because of the way that React updates the state. Sometimes there's a lagging where the mouse moves faster than the div. And then once that happens, like in this situation here, the div would get stuck. and the mouse would go outside, and then when the mouse up event triggered in that situation, it was still like the mouse was holding the div even though it wasn't. So when I tried to come back to the div, it would move the div around. So, but now it just makes the div stop moving, which is not like very good if you want to move the div fast, but it's better than not being able to select it again. And I think like leaving like this is also doesn't matter that much. So the question that I have is whether or not I should try to build something now. Should do a video for build space, or if I should just do like a small update to, and then try to like make a clickbait to tell people to click on the label. It feels kind of hacky to do that, but I think I probably gonna do that, but it's probably better to wait for when I have something to show at least. I don't think it makes a lot of sense to... I think there's a balance. Like, from their philosophy, it seems like they prefer more to... Which is kind of what I'm doing, but they advise you to like post as many launches as possible, as frequently as possible. And I think there is a balance there. I don't think that you should, for my philosophy, like post launch all the time, but at the same time it kind of depends on what you're doing, because on YouTube it's kind of like what I'm doing, where I'm constantly posting stuff, but on Twitter I think it doesn't make a lot of sense. Because then what happens is that I think on YouTube it makes sense because it's more like showing the process instead of showing the result of the thing. So when you're showing the process, I think it's fine to like post constantly, but on Twitter it's more like people are scrolling, so they're probably not gonna, unless they change Twitter. But I think it's gonna take a lot of time until that happens. I think that Twitter is more for when people are scrolling and they're not gonna have a lot of time. They're not gonna pay too much attention to stuff that you put there. So if you're constantly putting updates that don't matter that much, then what's gonna happen is that people are not gonna open like them. But at the same time, they said something that I think is also true, and it's kind of it's easy to forget, but because I'm putting content constantly out there, so it's easy to forget that people don't understand what you're doing. So like from their perspective, you're a nobody and they don't have any idea of what you're building. So, and this is a mistake that I think I do, of posting stuff as if everyone knows what I'm doing. But at the same time, it's kind of weird because then you have people that are following you and then they know what you're doing. So it's kind of weird to post like in a way that is almost something new. Let's say, like, it's kind of hard to explain, but I think it makes a lot of sense to post like that. So for example, saying stuff like introducing this so-and-so future, I think it makes sense because most people that are gonna see the post don't understand what you're doing, so it makes sense to always post as if it's new. But then if you're posting that every time that you do like a small change, I think that's kind of annoying as well. Like, I wouldn't want someone that I follow to do that, because then like it decreases the chances that you're gonna want to see their stuff. So I think there's a balance there, and this is the reason why I'm kind of debating on my mind if I should post or not another video, for the launch, just to send the updates. And I think that I shouldn't, but because I'm part of the thing, maybe I should, because it's just like not a big deal. Like, if I did it very often, then I think this is a big deal. But if I don't, like, it's just gonna be one extra update for this week, and then it's fine. So I think maybe I should. But I don't think I should try to develop something just for the sake. Like, try to develop a small thing that's gonna maybe have some... Maybe it's gonna create something useful that people can use on the node, on the graph. Because then it's gonna make me deviate from what I'm doing. I think it's just better to focus on trying to actually understand this stuff first, and then try to start working towards building the stuff that is actually gonna be useful. So. But who knows? Maybe I'm wrong about that. It's obviously possible. And this is what I mean, the flag variables that he uses should parse everything. I think I'm just gonna go over the course there, and then I'm gonna take keywords and then use ChatGPT to try to see. I'm gonna try to search for courses as well that are related to that. The problem is like code generator is not very good. I already have the instruction sets thing. Set architecture. String registration system. The question is whether or not I need this stuff as well. It's not exactly what I wanna do. Create the resolver. Not sure if resolver is worth putting there, because it's probably gonna be too generic, so I need more context. Structure of slots. This is a problem as well, because I do want to understand assigning variables, but if I put it like this, I think it's gonna be too generic as well. I think just with the module 1 is probably not gonna be enough. That's the problem, so I do need to research a lot more. And I also felt like this is the thing that I talked about last stream, that's there is definitely like a lot of knowledge that I don't have. That's it felt like it's just with the course alone, it didn't answer all the questions that I had about the whole thing. I think the first thing I'm gonna ask is about the import system. The problem is I have to ask based on, because I don't want it to explain to me how the import system works, and understand how it's built. So if I just ask how does the import works on JavaScript, it's gonna tell me about how to use it. I think it's not gonna be the browser, it's gonna be Vite or Webpack. Maybe I should just ask about Vite. Or Vite. Maybe this is another thing that I have to do that I forgot. Yeah, maybe better search terms are related to JavaScript and Python instead of trying to search for these generic things. Maybe I should start with the end thing and then, because I know there's a lot of resources that talk about Webpack and Vite. So maybe I should start with them first and then try to go back to the fundamentals from them. I'm thinking whether or not it's worth it to... The problem is that there's a lot of code, so I'm trying to think about the best way to compress everything. So I don't have to spend a bunch of time trying to understand how this stuff works. But maybe it's good to spend some time here. I think that's how it works here. It's probably based on the assembly the hardware architecture that's gonna be... It's gonna have its own assembly language, and I remember seeing that when I was studying assembly, that there's different types of assembly, and each one I think is related to one kind of operational system, and I think that probably the hardware architecture thing has to do with the assembly language, and that's on the compiler how you structure things so that it works on multiple different assembly versions. The fuck? I think I'm gonna use ChatGPT and ask questions about this repository. So I have to go back to this one. And then ask questions about this. Maybe this is the best way. So either studying Vite, trying to find... I think Vite's gonna be harder. If I'm not mistaken, it's written in Go, but I don't remember really well. And I think because it's newer, it's gonna have less resources, so it's gonna be harder to figure out stuff. Obviously, one thing that I want to do once I build the stuff that I'm trying to build is should use it to parse this other stuff, like the Vite and Webpack and all of these other things, so I can like learn more. But I think like in the beginning, maybe Webpack is better because it's gonna be a lot of resources, but either Webpack or V8 is probably a good starting point. And I think V8 might be better because V8 is the thing that is actually running, but actually Webpack is better because Webpack is closer to what I want to do. I think Webpack compiles everything, and then V8 is just the logic for running the thing. So maybe Webpack is better. So I think I'm gonna search for the Webpack source code. Then I download the code locally and then I go over it. So I'm gonna do both things at the same time, I think. I'm going to go over the course and study the course and then also study this at the same time. Oh, this is written in JavaScript. It should be easier. I'm gonna ask ChatGPT to explain. Yeah, let me read this stuff here with the text-to-speech.
Both Vite and Webpack are popular build tools for JavaScript applications, but they use different strategies to resolve imports. Vite is known for its fast development experience, and it leverages native S modules, ESM, in modern browsers to achieve this speed. Here's how Vite resolves imports. ESM support. Vite takes advantage of native ESM support in browsers, which allows it to directly load modules without bundling during development. This eliminates the need for a bundling step and speeds up the development server. Server-side resolution. When you import a module in your code, Vite's development server intercepts the request for that module and resolves it on the fly. It does this by using the native module resolution algorithm, which considers the import statements in your code and locates the requested module based on its URL. Dynamic import rewriting. Vite also supports dynamic imports. When you use dynamic imports, Vite rewrites them to ensure that the imported modules are loaded correctly, maintaining the native ESM behavior. Webpack. Webpack is a powerful and versatile bundler that supports various module systems, including common JS and AMD, in addition to S modules. Here's how Webpack resolves imports. Module bundling. Webpack's primary purpose is to bundle your application's code and its dependencies into a single or multiple bundles for production. During this bundling process, Webpack traverses your dependency graph to gather all the required modules. Configuration. In your Webpack configuration, you define how imports are resolved using the resolve object. This object then includes settings like alias to provide shorthand paths to modules, extensions to specify file extensions that should be considered when resolving imports, and more. Loaders. Webpack allows you to use loaders to preprocess files before bundling. This is particularly useful for non-JavaScript assets like CSS, images, and other file types. Loaders transform these assets into modules that can be included in the bundle. Code splitting. Webpack also supports code splitting, which allows you to split your bundle into smaller chunks that are loaded on demand. This can improve initial loading times by only sending the necessary code upfront and fetching the rest as needed. In summary, while both Vite and Webpack resolve imports to make sure your application's modules are correctly located, Vite takes a more native ESM approach that avoids traditional bundling during development, leading to faster development server performance. Webpack, on the other hand, focuses on bundling and code optimization, making it a great choice for more complex applications or projects that require extensive configuration and customization. Free research preview. ChatGPT.
I think Webpack is probably the way. Probably what I should do. Study Webpack first. It's gonna be easier because it's in JavaScript as well. Maybe another thing I could do is just, instead of trying to build everything from scratch, I just get the codes that already exist and then I put on some parts of the code my own logic to extract the information and then I build the graph that way. Maybe that's a better idea. Because then I don't have to think about everything. So like as I'm studying the thing, I put like logic that creates a graph based on the stuff that I'm studying. Maybe that's the best approach. And then based on that, I create the graph and try to use the graph to understand how everything's connected. Once I figure that out, then I slowly try to build from scratch everything and separate, because I think that the problem is, if I do it like that, then the problem is that it's going to be coupled with the one thing, so it's not going to be too generic. So it's better to... this is probably the best strategy. I start with this logic, like going over Webpack, then putting my own logic to create the graph based on entry points in the same way that I would use console log, for example, to see how different things work. But yeah, this is gonna have a lot of limitations, so this is a problem because it's not gonna allow me to do everything that I want to do, and which is gonna be require more fundamental thing. But maybe I can start with that and then slowly move to the other approach.
Webpack achieves module bundling through a multi-step process that involves analyzing your application's dependency graph, transforming and optimizing the modules, and generating output bundles. Here's an overview of how Webpack achieves module bundling. Entry points. You specify one or more entry points in your Webpack configuration. These entry points are the starting points of your application, where Webpack begins its analysis of the dependency graph. Dependency graph analysis. Webpack traverses the import statements in your entry points and recursively follows the dependencies of your modules. It creates a dependency graph that represents how different modules are related to each other. Module resolution. Webpack uses its configured resolve options to determine how to locate and load modules. This can involve resolving aliases, extensions, and other configuration settings to find the appropriate modules. Loaders. When Webpack encounters a module that is not plain JavaScript, for example, CSS, images, or other assets, it uses loaders to transform these files into JavaScript modules that can be included in the bundle. Loaders are configured in the Webpack configuration and are applied in a chain based on file type. Module transformation. After resolving a module and its dependencies, Webpack applies any configured loaders to process the module source code. Loaders can perform tasks like transpiling ES6 plus code to ES5 using Babel or optimizing images. Code splitting. Webpack supports code splitting, which means it can split your bundle into multiple smaller chunks. This is particularly useful for optimizing the initial load time of your application. Code splitting can be achieved manually by using dynamic imports or automatically based on predefined conditions. Chunking. The chunks generated through code splitting can be grouped into different categories based on your configuration, such as entry chunks, async chunks, and more. This grouping helps optimize how the chunks are loaded and shared among different parts of your application. Output generation. After processing all the modules and their dependencies, Webpack generates one or more output bundles. These bundles contain the transformed and optimized code of your application along with the necessary runtime code and metadata for managing modules. Optimization. Webpack also performs various optimizations on the generated bundles, such as minimizing code, removing dead code paths, and optimizing the order of module execution to improve runtime performance. Asset management. In addition to JavaScript bundles, Webpack can generate separate asset files for non-JavaScript resources like CSS, images, fonts, etc. These assets can be included in your HTML files using dynamically generated URLs. The final output of Webpack's bundling process is a set of bundles and assets that can be loaded by the browser to run your application. The configuration options you provide in your Webpack configuration file play a significant role in determining how modules are bundled, optimized, and delivered to the browser.
Yeah, I think V8 is probably not very good to start with, and I think it's gonna be because I just realized that V8 this is the thing that runs, and then the other things are the things that build the code. So it's obviously better to start with the other ones. So I'm not gonna focus on V8. I'm gonna focus on Webpack or Vite. So I think I'm gonna ask the question for the dependency graph thing. And like one quick thing that I could do is just highlight this dependency graph. But the other thing that I wanna ask is about Vite, how is it created, but I'm not really sure how old it is, so I don't know if ChatGPT is gonna have any information about it. Versus the statements. Where can I find Webpack creates the dependency graph analysis? So I'm gonna finish going over this here to see if there's any other keywords, and then I'm gonna study everything. So probably the best way is to study Webpack, and then as I study Webpack, I study the other project as well, and then I'm gonna try to start building this stuff. Like, probably gonna delete. I don't want to do this on stream. I'm gonna do this off stream, but I'm gonna delete a bunch of things here. And I don't want to do it on stream because obviously I'm gonna watch the course as I'm doing. So the course is on Udemy and is paid, so I don't want to watch the course on stream. So what I'm gonna do is just delete all the code, like not all the code, but most of the code, and I'm gonna follow along from scratch in the way that he does it. Maybe I'll go back to see if he builds the build file. I don't remember seeing him creating, and I think there might be a difference on the way that he does it because he's using Linux. So maybe when he puts make, it creates the build file automatically, but because I'm using Windows, it doesn't create. So I didn't pay attention to see if that's the case. But that's probably what I'm gonna do, and then I'm just gonna follow along manually, and then I'm gonna try to see if at certain points there will be a difference in the way that I will be approaching things, or the way that he does it. And then while I do that, I study the Webpack. So I'm probably gonna stream tomorrow as well, so I can separate the two things. I do this off stream, and then I do the Webpack thing on stream. And I'm gonna go over the source code. So the first thing that I think I'm gonna use ChatGPT and then search with ChatGPT, like use ChatGPT to help me find the files that I think that are gonna matter. Then I'm gonna create another project on the same folder that I have, that I'm creating this one here, but on a different, not in the same folder as this one, but on the parent folder of this one, I create another project for Webpack. Then I'm gonna write simple files. I think it's probably better to write in Python at first. So before I understand the C thing, maybe I should try to write. I think I'm gonna write it in C actually. Like Python is more comfortable because it's easier and I already have some experience. So C is gonna be more annoying because I have to figure out. The thing that I hate about C and C++ is that I have to create the header files, which just seems just very redundant and it's kind of annoying. And the other thing that's annoying is the make file as well. It's just a lot easier in Python. I don't want to build it with JavaScript because then I have to create a server, I think, with Node.js. And that's going to be, I think it's not very good. And probably, it's probably better to create with Python actually. Maybe I think I'll start off with Python and then later on I create in C. Because another benefit of creating Python is that I already have experience building backends in Python and APIs. So at some point I might create something Django to server, like that's probably what I'm gonna do. And like the front end is gonna send the data to the Django API. Then the Django API has the functions that convert everything. But obviously, so maybe, yeah, I think I'm gonna end up doing both because for some situations I think C is probably gonna be better. So, or C or any other language. The problem is that I don't have a lot of experience with the system languages, and I don't want to spend a bunch of time researching which one might be best, like C or Rust or Go. I think Go is more for front end stuff. Not really sure if it would make sense to do the stuff that I'm trying to do with Go. So I think I'm probably gonna use C for some parts, and then I convert the code from C in Python. So I build the graph in C, then save the graph as a JSON file, and then on the Python server, I grab the JSON, or I create, yeah, maybe I can grab it programmatically, or I can send the data. The thing is, I don't know if I have to research. I think it's gonna be harder to build like a server or something in C. Not really sure if that's possible or not, because I don't really know. I think C, I know games are created in C, C++, and system level stuff, but I'm not really sure if it's very used to build servers and other things like that. Obviously, it needs to have some. I think it does, obviously, because now that I realize that, like, if you build the operational system in C, then you're gonna build the network protocols as well. In the operational system, he doesn't talk too much about it, about network, unless I don't remember really well. But I think he doesn't. If he does, he doesn't go very in depth into it. So, but there's probably stuff on C too. So maybe I should do it in C in the beginning. Yeah, I use ChatGPT, then I grab the files that I think are gonna be interesting to analyze. Then I put the files, or maybe it's better to put the whole project, like Webpack, inside of the thing. I think I'm gonna do that right now. So I put here, and the question is if I should put on this one. No, maybe this one. This one is better for the other one. So maybe start like here, and then I use some stuff that I built here. That's probably what I'm gonna do. So I built the beginnings following the course of this one. Then on the other project, I copy some of these files on the other one, like the whole structure, which is gonna be the most annoying. And then once I have that, I'm gonna put the Webpack on this folder, and from this folder, I try to read the files like from Webpack, and then try to create the graph from there. And initially, I have to research as well. Maybe I will ask this now for ChatGPT, because one approach is to save the files as JSON, and the other approach is to try to send them uh, through a network protocol. So right now, I'm not gonna do that because it's gonna take a lot of work to set up the API and deploy things. This is gonna be very annoying. So it's probably better to just save on JSON format first. But it will be useful to know if like how hard it's gonna be to send the information directly, because obviously what I'm like, first I'm gonna create the proof of concept thing, and I'm just gonna manually save the JSON files and then read the JSON, get the JSON files, the graph from the JSON files on the front end. So I'm gonna manually put the folders there on the front end, and then the functions are gonna read from the JSON files. But when it's time to scale, once I optimize the graph visualization and the systems and everything that I'm gonna do, which might take a lot of time, then obviously I'm gonna scale for having a bunch of different projects. And another approach is to also study how to sandbox the user and then allow people to put their own code. But once it gets to that point, then obviously what I'm planning to do is to make an API call. So when the user interacts with the page, it makes an API call, and then depending on the API call, the server is gonna send the information for the server, or it's gonna say, it's probably gonna send like an URL or something like that. And then the server will do the job of locating the code and creating the graph. So I think I need to see if which one is gonna be better to do it, like with Python or with C++. Maybe I can find the code. Like one approach is to download the whole code and have the code on the server. The other is to make it programmatically do the requests. So it's kind of like using Yarn or other package manager, which is just gets the code from somewhere else. Then once it gets the code, it parses everything. I think that probably the best thing is going to be both at the same time, because it will be better to have the code. Because having the whole, I think I'm going to have to have the code. No, like that's the main thing that I'm planning, because it would be nice to have several different projects at the same time, because that way I can analyze multiple projects at the same time. But obviously I can do the same logic just by doing multiple requests. But I don't like that much of having to depend on doing the requests to get the code. So, but in some situations that might be better. But the point is that I have to see if on C that's gonna be very hard to do or not. So I think I'm just gonna ask ChatGPT for this stuff. I'm gonna try to see if there are libraries in C or how that works. Also, that's something I have to study more, because it's kind of hard for me to understand, because I'm so used to the other languages where you just have the package manager and it gets the libraries, and I think in C is very different. Yeah, oh. So I'm gonna ask this now as well. So let me close this. Yeah, that's a good plan, I think. So I'm gonna delete this stuff here. So the first thing I'm gonna ask is the thing about the network requests on C. Then I clarify the imports more. I'll do everything later. I'm creating the make file and all the other stuff that I need. So semantic, validation. I already have these keywords on the other projects, so I'm not gonna. So I think those are the only useful keywords here. I'm gonna put here keywords research. I think keyword research is useful if I have the stuff that I want to do in mind. Otherwise, it's not very good. So it's better to have here, and then as I do the other stuff, I research once in a while these keywords here. When I think that is the point where they're gonna be useful. I think I'm gonna be right back, and once I come back, I'm gonna ask ChatGPT this stuff and try to clarify how does it work. So I'll be right back. I'm going to do some keyword research off stream, and then I'm going to just rest and continue tomorrow.
Webpack's dependency graph analysis is a core part of its internal process, and the source code for this can be found in the official Webpack GitHub repository. You can explore the repository to gain insights into how Webpack handles module resolution and builds the dependency graph. The repository is organized into different directories and files that correspond to different aspects of Webpack's functionality. The specific files related to dependency graph analysis are usually found within the core of Webpack. Here's a general path you might follow. Webpack GitHub repository. https://github.com/webpack/webpack. Dependency graph code path. Inside the repository, navigate to the core part of Webpack. The specific code files related to dependency graph analysis, module resolution, and building the graph are usually located in directories like lib or lib/dependencies. Key files. Some of the key files related to dependency graph analysis include dependency.js. This file defines various types of dependencies that Webpack handles, such as common JS dependency, import dependency, etc. Normal module.js. This file represents a normal module in the dependency graph and contains logic for resolving and processing dependencies. Parser.js. This file handles the parsing of module source code to extract import statements and other relevant information. Module graph.js. This file is involved in managing the graph of modules and their dependencies. Please note that exploring the source code of a complex tool like Webpack might require a solid understanding of JavaScript, Node.js, and build tools. Additionally, the codebase might change over time as new features are added and existing code is modified. Free research preview. ChatGPT may produce inaccurate information about people, places, or facts. ChatGPT August 3rd.
I'm going to ask questions about Vite now. Then the questions about C. Oh, so is it written in TypeScript? So this is another one.
Vite, like many modern JavaScript tools, is built using JavaScript and Node.js. It's primarily written in JavaScript, which is the language commonly used for creating Node.js applications and build tools. Vite's source code can be found on its official GitHub repository. Here's the link to the repository, Vite GitHub repository. In the repository, you'll find the source code organized into different directories that correspond to different parts of the Vite tool. You can explore the repository to learn more about how Vite works, its internals, and its implementation details. Keep in mind that understanding and navigating the source code of complex tools like Vite might require a good understanding of JavaScript, Node.js, and the specific tool's architecture. It's also a good practice to check the documentation, guides, and any community discussions related to the tool, as these resources can provide insights into the design decisions and usage patterns of the tool's codebase.
I have to look at the course again, the operational systems, to see if it says anything about network requests. I don't remember him saying stuff about that. Let me just see here if there is on the topics anything about this. The operational system course is from the same guy of the compiler course. It's technically not operational system, multi-threaded kernel, but it's pretty much the same thing. So let me see. There's just stuff about file system, task switch, userland. Interrupt. Then the keyboards. The terminal. Memory. Yeah, there isn't any. It looks like there isn't anything about network requests. And maybe this is like it is separate from the operational system technically. It's probably an external library. I guess it would be a good thing to do it in C because then it forces myself as well to learn. And I know that Python usually uses URL lib3, and like most of the time I think people are gonna use the requests library, and the request library uses URL lib3 under the hood, and then URL lib3. There was a mistake that I got that was very hard to understand what happens, and I still don't understand very well. But I used ChatGPT to try to figure out, and from what I remember, at some point URL lib3 calls something from Windows, because the Windows software is going to create a proxy request. A proxy request is going to create a proxy which maps to the internet. So every request goes through the proxy, and then Windows is managing that. And urllib calls something that calls that proxy. And it creates like pools, and then it caches the pools and the things sometimes, but it's hard to understand because the mistake that I was having is that I couldn't open a new connection because all the connections were taken, and I think it's because I wasn't closing the connection after I ran the script. So every time that you run, the urllib I think saves the connection somewhere, but it's kind of hard to understand how and what is going on. And then I know that you can use netstat, and I also researched some stuff about network requests with Windows, so I know that there's programs for that. I don't remember really well what's the name of the thing, so maybe I should ask these questions about, because I think most of this stuff is going to be related to C as well. Like trying to do the network requests on C might allow me to understand more, because another way to do network requests is using curl, which is a program on the command line, and maybe that's closer to the way that operation system works.
In C, handling network requests typically involves using sockets, which provide a way to establish network connections and exchange data between machines over a network. Here's a basic overview of how to handle network requests in C using sockets. Include required headers. You need to include the appropriate headers for working with sockets. The most common headers are sys/socket.h and netnet/in.h create a socket. Use the socket function to create a socket. This function returns a socket descriptor that you'll use for further operations. C copy coding socket_desc equals socket af underscore net socket_stream 0 if socket_desc equals -1 / handle error. Configure the server address. Configure the server's address and port you want to connect to using a struct socket underscore in .c copy code struct socket underscore in server. Server.sin underscore family equals af underscore net. Server.sin underscore port equals port / port is the port number. Server.sin underscore address .s underscore address equals net underscore address server underscore IP / server underscore IP is the server's IP address. Connect to the server. Use the connect function to establish a connection to the server.c copy code. Connect socket underscore DSC struct socket and server size of server equals -1 / handle error. Send and receive data. You can use the send function to send data and the rec function to receive data over the socket.c copy code char message equals hello server if send socket underscore DSC message string message 0 equals -1 / handle error char buffer 1024 if rec socket underscore DSC buffer size of buffer 0 equals -1 / handle error. Close the socket. After you're done using the socket, close it using the close function.c copy code close socket underscore DSC. Please note that handling network requests can be more complex depending on the specific use case and the type of communication you need to establish, TCP or UDP. Additionally, error
Maybe before this, I'm going to ask a question about I forgot something related to C. Oh, the server.
While C is a powerful and low-level programming language, it's not as commonly used for creating servers and APIs compared to higher-level languages like Python, Node.js, Java, and others. However, it's still possible to create servers and APIs in C, especially when performance is a critical factor and the application requires fine-tuned control over system resources. C is often used in scenarios where you need to create specialized or embedded systems. There are a few libraries that can help you create servers and APIs in C. GNU-libmicro. This library provides a simple API for creating HTTP servers in C. It's relatively lightweight and can be used to build basic HTTP-based APIs.citweb. This is a small and embeddable HTTP server library that's written in C. It's designed for simplicity and ease of use. Wait, pronounced. Witty. Wait is a C++ library that provides an application server framework for building web applications. While it's primarily C++, it also supports C interfaces and can be used for creating web APIs. Basic REST API architecture in C might involve the following steps. Choose a library. Select a suitable library for creating an HTTP server. For example, you could use GNU-libmicro or citweb.define routes and handlers. Define the routes, endpoints, of your API and associate them with handler functions. These handlers will be responsible for processing incoming requests and generating responses. Parsing requests. In your handler functions, you'll need to parse the incoming HTTP request to extract information like the HTTP method, headers, query parameters, and request body. Process logic. Implement the logic for each API endpoint. This might involve interacting with databases, processing data, or performing other business logic. Generating responses. After processing the request, generate the appropriate HTTP response. This includes setting response headers, status codes, and generating the response body. Sending responses. Send the generated response back back to the client using the appropriate functions provided by the chosen library. Error handling. Implement proper error handling for various scenarios, such as invalid requests, internal errors, and more. Testing. Thoroughly test your API to ensure that it works as expected and handles different types of requests gracefully. Remember that creating an API involves more than just writing code. You also need to consider security, scalability, and maintainability. If you're aiming for a more feature-rich and scalable solution, you might consider looking into frameworks like Express.js for Node.js or Flask/Django for Python, which provide higher-level abstractions for building APIs and web applications. Integrating a C lexer, parser, and code generator into a Python API involves bridging the gap between the C code and the Python environment. Here's a general approach you can follow. Compile C code into a shared library. First, compile your C lexer, parser, and code generator into a shared library. For example, a dynamic link library or a shared object file. This library will provide a way for Python to interact with your C code.use. The types library. Python's types library allows you to call functions from shared libraries directly from Python. You'll need to create a Python interface for your C functions using the types module.define. Python wrapper functions. Create Python wrapper functions that correspond to the C functions you want to call. These wrappers should use types to load the shared library and call the appropriate C functions. You can use the CDLL class from types to load the library.parse files and generate structures. In your Python API, use the wrapper functions you created to parse files using your C lexer, parser, and code generator. Call the C functions to perform the parsing and generate the desired structures.use. The Python API for interaction. Expose the Python API methods that allow users to parse files and retrieve the resulting structures. Users of your API can now call these methods to perform parsing from within their Python scripts.serialization and communication. If you want to send the resulting structures to a Python API, which seems to be a separate component, you'll need to serialize the data in a format that can be easily transmitted. JSON is a common choice for this purpose. Serialize the resulting structures in your C code using libraries like JSON or your own serialization logic.b. In your Python API, receive the serialized data and deserialize it using Python's JSON module.expose. The deserialized data. Once the data is deserialized in Python, expose methods or attributes that allow users of the Python API to access and work with the parsed data. Remember that there might be challenges in managing memory, data structures, and potential differences in calling conventions between C and Python. It's important to thoroughly test your integration to ensure that the data is being parsed correctly, structures are generated properly, and the interaction between C and Python components is robust. Additionally, this integration approach might introduce some performance overhead due to the interlanguage communication. If performance is a critical concern, you could explore alternatives like using a C extension for Python, for example, Cython, to directly incorporate your C code into Python without the need for external shared libraries.
This is probably the best approach. So I build everything on the front end with JavaScript, then I build an API on Python, and then I build the compilation process or the creation of the graph on C, and maybe some parts in Python as well. And I remember now that there is some libraries and some versions of Python that allows you to write a different kind of Python that is more C-like. So this is probably the best approach. So the bridge between the two, there's probably going to be some tools that are going to make it easier. But I should probably start with building the stuff on C first, and then I build on JSON directly. So I'm going to ask questions. After I ask this question, I'm going to ask questions on how to save, which I think is not going to be hard. It's just going to be the write. You use the write flag to write the file in JSON. So I just build the graph on C and then write it to the JSON file. Hopefully it's not that hard. Then I use that JSON file and manually put on the front end. Then I optimize like manually with a couple of libraries that I'm going to analyze. And then once the graph and the system is better, then I can scale. And when it's time to scale for a bunch of different projects, I'm going to create something in Python. I think that's the best probably. But it's going to be very annoying in the beginning to build this stuff on C. So this is probably the reason why when I start with Python, but it's just myself trying to rationalize to not do the hard thing, because I know it's going to be uncomfortable in the beginning, it's going to be slower. So I think that's for this reason I should probably do it in C. Should get out of
NetStat.
my
NetStat
comfort
is a command
zone.
line tool available on various operating systems, including Windows, Linux, and Mac OS. It provides information about network connections, routing tables, interface statistics, masquerade connections, and more. By running NetStat with specific options, you can see details about active network connections, listening ports, and various networking statistics. For example, you can use NetStat on Windows to display all active TCP connections and listening ports, along with their associated IP addresses and port numbers. Windows proxy handling. In Windows, proxy settings are used to route network traffic through a proxy server, which can be beneficial for security, caching, and content filtering purposes. The Windows operating system allows users to configure proxy settings at a system-wide level or for individual applications. Proxy settings can be configured in the Windows Settings app or through the Internet Options dialog in the control panel. Applications that support the system proxy settings will automatically route their network traffic through the configured proxy server. Erlib3 and Windows proxy system. Erlib3 is a powerful HTTP client library for Python that provides connection pooling, request and response handling, and other useful features. It's commonly used to make HTTP requests from Python scripts. The relationship between Erlib3 and the Windows proxy system is that Erlib3 can utilize the Windows proxy settings if they are configured at the system level. This means that when you use Erlib3 to make HTTP requests, it can automatically route those requests through the configured proxy server if the Windows proxy settings are in place. To achieve this, Erlib3 can leverage the WinReg module for Python 3 to read the proxy settings from the Windows registry and then configure its underlying network connections accordingly. In summary, when Erlib3 is used on a Windows system, it can seamlessly work with the Windows proxy system if it's configured, allowing your Python scripts to make HTTP requests through the system proxy server. Remember that proxy settings can vary based on the network environment and security policies. Therefore, it's essential to understand the proxy configuration in your specific environment and consider how it interacts with the tools and libraries you're using. Erlib3 is a Python library that provides connection pooling for HTTP requests. Connection pooling allows you to reuse existing connections to improve performance and reduce the overhead of establishing new connections for each request. While Erlib3 doesn't cache connections in the traditional sense, it maintains a connection pool that facilitates efficient reuse of connections. Here's how Erlib3 manages connection pooling. Connection pool creation. When you use Erlib3 to make an HTTP request, it checks if a connection pool exists for the target host. If not, it creates a new connection pool. A connection pool consists of multiple persistent connections to the same host. Connection. Reuse. For subsequent requests to the same host, Erlib3 checks the connection pool to see if there's an available connection that can be reused. Reusing connections avoids the overhead of establishing a new TCP connection, which can significantly improve performance. Connection. Limits. Connection pools in Erlib3 have configurable limits on the maximum number of connections that can be created and the maximum number of connections that can be kept alive in the pool. This helps prevent excessive resource usage while still maintaining efficient connection reuse. Connection. Health checking. Connection pools can also perform health checks on connections to ensure that they are still valid before reusing them. If a connection becomes stale or invalid, it is closed, and a new one is created. Thread. Safety. Erlib3 connection pools are designed to be thread safe, which means they can be used in multi-threaded applications without causing issues related to concurrent access to the connection pool. Connection timeout. And keep alive. Erlib3 manages connection timeouts and keep alive headers automatically. When connections are reused from the pool, Erlib3 ensures that they are still valid and functional. It's important to note that Erlib3 connection pooling is focused on managing connections efficiently within the context of an HTTP client. It doesn't cache responses or entire requests like a caching mechanism would. Connection pooling aims to improve performance by reducing the overhead of establishing and tearing down connections, allowing multiple requests to reuse the same underlying network connection when possible.
It's probably not gonna give me anything. I need to remember the keywords, and I forgot. There was like some system or some function somewhere that had a keyword that was the connection between urllib3 and Windows, but I don't remember really well.
The connection pool in Erlib3 isn't directly connected to the Windows proxy system itself. Instead, it can leverage the proxy settings configured in the Windows operating system to route HTTP requests through a proxy server. The connection pool manages the reuse and pooling of underlying TCP connections, while the proxy configuration determines how those connections are used to interact with the network. Here's how the connection pool in Windows proxy system can interact. Proxy configuration. In the Windows operating system, users can configure proxy settings at a system level. These settings determine whether network traffic, including HTTP requests, should be routed through a proxy server. Proxy settings include details like the proxy server's address and port number. Erlib3 and proxy configuration. When you use Erlib3 to make an HTTP request, it can read the proxy settings configured in the Windows operating system and, if applicable, route the request through the proxy server. This is particularly useful when the Windows proxy settings are set at a system-wide level. Connection. Routing. When a request is made using Erlib3, the connection pool checks if a connection to the target host already exists in the pool. If a connection doesn't exist, it may establish a new one. Proxy. Handling. If proxy settings are configured and the request is destined for a URL that requires routing through the proxy server, Erlib3 will direct the request through the proxy by sending the request to the proxy server's address and port specified in the proxy configuration. Transparent 2. The connection pool. The connection pool itself isn't directly concerned with proxy routing. The proxy configuration is typically handled transparently by Erlib3 when it constructs the HTTP request to be sent over the established connection. To summarize, the Windows proxy system configuration provides the information needed to route network traffic, including HTTP requests, through a proxy server. Erlib3 can read these proxy settings and use them to route HTTP requests through the proxy server if necessary. The connection pool, on the other hand, focuses on efficient management and reuse of underlying TCP connections to improve performance when making multiple HTTP requests to the same host.
This is the last question that I'm gonna ask about this, I think. And then I'm gonna ask questions about Webpack and vids, and I'm gonna go over the files. So first I'm gonna focus on building something from Webpack, and then once I have something from Webpack, then I can think about the other stuff. Actually, very later on. So I focus on. Well, this is the stuff that I was gonna ask about the JSON file.
The connections between erlib3 connection pooling and the Windows operating system primarily involve how erlib3 leverages the Windows proxy system and other networking features to facilitate efficient HTTP request handling. Here's an overview of the connections between these two components. Proxy configuration. erlib3 can read the proxy settings configured in the Windows operating system. These settings include information about the proxy server's address and port number, as well as any authentication credentials required for proxy authentication. Connection pooling. erlib3 maintains a connection pool that allows multiple HTTP requests to reuse and share the same underlying TCP connections when connecting to the same host. This minimizes the overhead of establishing new connections for each request. HTTP requests. When you make an HTTP request using erlib3, it constructs the necessary HTTP request headers and payload. Proxy routing. If proxy settings are configured in Windows and the target URL requires routing through a proxy server, based on the scheme of the URL, erlib3 will route the request through the proxy by sending the request to the proxy server's address and port specified in the proxy configuration. Connection reuse. If a connection to the target host already exists in the connection pool, erlib3 will reuse the connection for the new request, improving performance by avoiding the overhead of establishing a new TCP connection. Transparent handling. The proxy routing and connection reuse are handled transparently by erlib3. The user typically doesn't need to manually manage these aspects. Connection health and keep alive. erlib3 ensures the connections in the connection pool are kept alive and functional by periodically performing health checks on them. This includes handling keep alive headers to reuse connections efficiently. Windows networking stack. The actual network communication, including establishing and managing TCP connections, is facilitated by the Windows networking stack. erlib3 interacts with this stack to create and manage the underlying TCP connections used for HTTP requests. Socket management. erlib3 uses standard socket APIs provided by the operating system to create and manage network connections. In summary, erlib3 connection pooling and the Windows operating system interact to provide efficient HTTP request handling with features like connection reuse, proxy routing, and connection health management. The connections between these components are designed to abstract the complexities of networking and proxy configuration, providing a seamless experience for making HTTP requests in Python. Free research preview. ChatGPT.
Yeah, this is what I imagine it would be. So I could just use the function from the other project that reads and writes the file. So you pass the file name, and then based on that, it reads, and then if you pass the out name, it writes. So I can just pass the Webpack file as the first argument, and the second argument is going to be the JSON file. But the thing that I'm not really sure about is that if this function is going to work with the data structure, or if we're going to write everything as characters. But if that's the case, if it works or not, even though it's writing everything on characters, because it's going to be, obviously I want the file to have graph formats. Actually, I have to spend time because I don't remember if this is the parts, if this is the file that he puts all the other logic of, I think it has to be. Just now, the last part that I was watching on the course before I started streaming today, he creates something, but I think it's on the compiler file, not the C process, that he separates everything that is gonna, like the main functions that are gonna run for each thing. Because obviously you have to get the file and then you do all the operations to create the data structures. And then after you do that, then you write, I think. So I'm not really sure if this is like how I should do it, or if I should just copy this function and then modify this function to uh, do what I wanted to do. And this arrow operator here, the only thing that it does is like the dot operator, but for things that are dereferenced. So for pointers in memory. So instead of having to dereference the thing to access it, because a pointer is just when you use a pointer, you're just accessing the location of where the thing is in memory and not accessing the thing itself, the data. So in C, when you want to access things, when you want to access the thing itself instead of the pointer or the address for the thing, you have to dereference the thing, and then you have to use another pointer or something like that. But the arrow operator allows you to do these two things at the same time. So, and he mostly uses to access stuff on the structs. So it's pretty much like the dot operator, but a little bit fancier because of the pointers. Yeah, symbol resolver is probably the thing that is gonna divide the stuff on lexers. It's gonna create the lexer, the tokens with the lexer. So I'll look into this later. I'm gonna ask questions about the Webpack.
As of my last knowledge update in September 2021, the Webpack project's repository structure might have changed since then. However, I can provide you with a general idea of the typical folders and files that are often involved in the dependency graph analysis within the Webpack project. Keep in mind that the actual structure might have evolved since then. lib/and lib/dependency/directory. The core logic of dependency graph analysis is usually located in the lib/directory, specifically within the lib/dependency/subdirectory. You might find key files related to module resolution, dependency parsing, and graph construction in this area. lib/dependency/dependency.js. This file often defines different types of dependencies and their logic.lib/normal module.js. This file represents a normal module in the dependency graph and might handle resolution, parsing, and dependency management.lib/parser.js. This file is responsible for parsing module source code to extract import statements and other relevant information. lib/modulegraph.js. This file could manage the graph of modules and their dependencies. lib/compilation.js. This file is involved in the compilation process, which includes module bundling and optimization. The dependency graph analysis interacts with this file during compilation to generate output bundles. lib/resolver.js. The resolver is responsible for resolving module requests to file paths. It's a crucial part of dependency graph analysis as it helps locate and map modules based on import statements. lib/graphhelpers.js. This file might contain utility functions for managing the dependency graph, creating connections between modules, and handling dependencies. lib/template.js. Templates in Webpack define how modules are transformed and wrapped within the output bundles. The template logic can be related to dependency graph analysis. Please note that Webpack is a complex tool with many moving parts, and the repository structure might have evolved or undergone changes since my last update. If you're specifically interested in exploring the dependency graph analysis aspect of Webpack, I recommend visiting the official GitHub repository and navigating through the lib/directory and its subdirectories to find relevant files related to module resolution, parsing, and dependency handling.
Yeah, there is no file for dependency. Normal module parser. There's also no file about that. So maybe it's outdated. But I think these ones here are probably like related, if not the same thing. So I'm going to look into these files first. And the hard part is that there's so much stuff, and it's hard to know how, like, what is the best trajectory, like the best path to go from file to file, function to function, to try to understand what is going on. Because the concern that I have is that it's gonna be too much like in the air, let's say. Like I don't have any context of the bigger thing of when these things are gonna be called. So just looking at the source code is not gonna allow me to like understand what are the variables that are being received and what is happening. So, but over time, I think it's gonna become easier and easier. Just in the beginning is hard, and then becomes easier. This is another thing that I talked about yesterday as well. That is like it's still hard to understand or to think about. Is that like this is obviously using JavaScript itself, so it doesn't tell me anything about where the stuff comes from, where the import system comes from. Is using JavaScript to solve the other stuff, which is difficult to think about because I'm still not clear on the thing that I'm gonna do and how like to resolve that in my mind about the differences. Maybe I'll ask file by file. But I believe like the difference between this answer here and the files that exist there is probably that you got more specialized over time since ChatGPT was last updated. So now there's a bunch of different files for each single thing, and then the whole folder. The point of the folder, I think, is just to resolve the imports. So I'm going to spend a lot of time here first, and then try to understand the logic. Maybe it's not a good idea to. I have to think about this. Like, if it is a good idea to grab these files and then, because on this project here right now, I was thinking that I was gonna build the file and then read the files on Webpack, but that doesn't make a lot of sense now that I think about it. Like, it's probably better to study the Webpack files and the logic here, and then try to mimic the logic here, but in C to resolve the imports on other files. I think that's what I have to do. Instead of, but obviously I can use this thing with the, this is another thing that is going to be extremely annoying, which is the differences in imports that JavaScript has. Is there's a bunch of different systems. It's just like very, I don't understand why. There's CommonJS and then ESM. It's probably just because of the way that things evolved, but it's still fucking annoying. Just I can parse these files as well, like use the thing. So try to build the stuff similar to the way that it is here, and then use on this thing as well to try to resolve the imports here, and then I create the graph. So, but instead of resolving the imports, I create the graph. So I think what I have, the other approach is just to think about like how would I do it if I didn't have the tools. Because I just realized that now that probably it shouldn't be that hard. What I can do is just set some conditions of depending on the way that the thing is, that's it's gonna be a local import or not, and then if it is not a local import, that's probably the thing that I have to figure out, because the local imports are very easy probably. You just put the logic for finding the path here, and then based on the path you find the file. Or you just use the path, because I'm gonna be using the, like C is gonna have the libraries that are gonna allow me to open the file if it exists on the project. So I think relative imports are easy. The ones that I have to figure out is how do they do it with the other imports. But isn't all of them are gonna be on the node modules thing? So we have to download them first. So it's gonna be based on the package manager. Yeah, maybe I'm conflating this stuff. But obviously there's a lot of code here, so there's a bunch of stuff. I just realized now that you're gonna use like I'm conflating the package manager with with Webpack. Yeah, but there's also bundling. So the Webpack bundles the things. It just gets all the imports and puts everything on the file. So maybe getting the imports, like I can create a graph that connects all the imports. It should be easy to do. It's just getting the files from the node modules. But I have to understand here as well, I think, this other stuff because it's definitely important. Maybe this is the first thing I should do. I should forget about studying this code and just try to do it based on the way that I'm thinking now on my head, which is just create heuristics. It's gonna be a problem because of the differences in parts, but I can just use the like pattern matching as well. So I can create heuristics of each type of import and the path in C, and then I create a graph that connects all the files that are imported. So I built like a direct graph that has like each file is going to be a node, and then the files that it imports are other nodes. The name of the path, the name of the node, the label is going to be the file. And maybe that's interesting thing to do. Then the hardest part would be to create. I guess I'll think about this later. Yeah, I'm going to do that. I'm going to forget about. So the first thing that I'm going to do is to think about off the top of my head, like how would I do it if I don't have the stuff? If I was starting from scratch and I don't have anything, how would I solve? And I think the plan is going to be to create some logic that determines what kind of pattern it is on the file. So one question that I have is how do I make sure that I think I don't need to make sure the file has other, like, well, maybe I do actually, because you can have a situation. Obviously, I think that's not going to be the case, but it would be possible where you have like this, but maybe it's not even possible on JavaScript. But I think it is though. So if I have a situation like this, how do I know that this is not going to be an import? But for now, for the beginning, it probably doesn't matter because the code is unlikely to have, and if it has, it's going to be very like rare. So probably the best thing to do is to create some logic that is going to check whether or not this pattern exists of the import, and I can use ChatGPT to get a regex or something like that of the pattern. Then, based on the pattern, I get the location of the files, and then I create something that explores each files. So, and creates the graph. So I can create a function that's based on this pattern here in the path. Is gonna create the edge. So it creates the node based on the name of the files. So like I create a function that reads the folders, and so I guess this is the one question. So I need to see if there's a function on C, or if I'm gonna have to create on my own of that gets all the goes over the folder and reads all the folders and files that exist on the folder. And that's what I'm thinking about doing. So I create this function, and then this function is gonna read everything, and then each name of the file is gonna be each file is gonna be a node. And then from that node, I create the graph of the dependencies. So I'm gonna pattern match based on what files is importing, and create the different edges for the paths. And I don't need to use the paths because I'm gonna read through all the files anyway, so I can just connect. It's gonna be very easy, I think. Because the other thing I was thinking about is that based on the path, I can navigate through the path instead, but it doesn't matter. It doesn't make a lot of sense. It makes more sense to just go over all the files, and then I can just create the edges based on the file path. Oh, but the problem is, like, maybe I do need to think about the path. Like going file by file based on the path and not based on reading, because or not, or I can just pattern match based on the file name. Because what I want is not the connection of the file with the file path, is the connections of the files based on what the files are importing. The biggest problem is the external imports, but I think that for the external imports, it's probably just gonna be on the node modules. So, and maybe I don't do it with Webpack first, because Webpack might be different. It is gonna be different, I think. Maybe not. But I can do it with React. The thing is, though, that yeah, in the beginning I'm gonna do it like this, but I'm gonna have to figure out how the import actually works. I have to figure out a way, maybe not even how the import works, but how to resolve the absolute import without downloading the library. That's the thing. Or maybe not, because like instead of installing each library locally for each project, I'm gonna have a global list of libraries, obviously. Because you can imagine, let's say that there's gonna be different projects that are gonna be using the same libraries. For example, like some project uses React and the other project uses React as well. So obviously it doesn't make sense to download everything locally for each project, because then it's just gonna be a lot of space that I'm gonna use that is not necessary. So it makes more sense to have a global list of the modules. But then the difference is obviously the file path, like how I'm gonna resolve. I have to create something that is gonna resolve based on the global modules thing. This is the thing that I think I'm getting confused, because like one approach is to download everything and then I resolve locally based on the global list, and the other one is based on the name. I can do a network request in the same way that package managers do, and then I can get the code. But then I have to check if it exists or it doesn't exist. Maybe I don't need the code, I just need the name. But in the beginning, I'm probably going to do it like this. So I'm going to start doing like this tomorrow.
Webpack resolves imports from external libraries using its resolver mechanism. The resolver's job is to determine the location of modules based on import statements and to locate the actual file paths for those modules. Here's an overview of how Webpack resolves imports. Resolver configuration. In the Webpack configuration, you can specify resolver options using the resolve object. This object contains settings that influence how Webpack resolves imports, including alias, extensions, and more. Module request. When you use an import statement in your code, such as import module name, Webpack receives a module request representing the imported module. Resolution process. Webpack's resolver goes through a sequence of steps to resolve the module request. Alias resolution. If you've defined aliases in the configuration, the resolver checks if the requested module matches any of the defined aliases. If there's a match, the alias is used to determine the actual file path. B. Module name resolution. If the module request doesn't match any aliases, the resolver attempts to locate the module module in the node_modules directory. It looks for a folder with a given module name under node_modules.c. File extensions resolution. Webpack checks for the module with various file extensions. For example, JS.jsx, CSS, based on the extension's configuration. If the module name in the import doesn't include an extension, Webpack tries different extensions until it finds a matching file.d. Module directory resolution. If the module name matches a folder inside node_modules, Webpack checks if the folder contains an index file. For example, index.js, as specified in the main field of the module's package.json. If found, that file is used.e. Fallback paths. Webpack also looks for modules in fallback paths specified in the configuration, such as fallback or fallbacks. These paths can be used to specify additional directories to search for modules.package.json resolution. When resolving modules in the node_modules directory, Webpack also looks at the package.json file of the module. The main field of the package.json indicates the entry point for the module. If the module request corresponds to a package, Webpack uses the specified entry point to determine the actual file path.custom. Resolvers. Webpack allows you to use custom resolvers by defining plugins that implement the resolve method. These plugins can modify the resolution process, handle custom module types, or provide additional logic for locating modules. In summary, Webpack resolves imports from external libraries by following a sequence of steps defined by its resolver mechanism. It checks aliases, searches in node_modules, examines package.json files, and applies extension handling to determine the actual file paths of the imported modules. The resolver's configuration settings influence how this resolution process takes place.
So I'm obviously very confused still, but yeah, I'm gonna stop here, and I decided to stream today just to like show this process of thinking about these things. But I knew that I wasn't gonna do anything today, so I'm just trying to clarify more, like what is the thing that I can do like first that makes sense for the overall vision, but at the same time it's not gonna be something like really easy that doesn't make sense, like because I think that would be a waste of time. So I'm trying to clarify what's the best thing that I can start with. And obviously all of the things that I'm gonna do, like regardless of which way I'm gonna go, it's gonna be really hard because there's like billions of files of each thing. So I have to clarify what I'm gonna do. But I think now, like it's getting more clear of the direction it's probably better to start with. And I think the direction I'm gonna go, so I'm going to study more Webpack first because I want to understand more how they approach this. So I'm gonna try to use ChatGPT. Probably next time data stream, I'm gonna try to use ChatGPT and go over the source code to see like what are the functions that, what is all the logic that is they use to resolve the imports. And then I'm gonna try to create something in C that reads all the files and the directories of a directory, and based on them creates a graph network that represents all the connections of the different files based on the paths. And then once I have that file, I'm gonna save on JSON. Once I have the JSON file, I'm gonna put on the front end, and I'm gonna create the graph and animations based on that. And then once I have the link, then I'm gonna try to iterate on top of this and improve. And I'm gonna have to spend a bunch of more time thinking about what is the best way to go about improving this and like which direction to go, because there's so many things. But I think that probably what I'm gonna try to do is to use the stuff that I'm building to see, like to think about how I can make it so that the stuff that I can use the stuff that I build to make it easier to study this complex stuff. I think that's the best approach. So like from building the dependency graph of the Webpack stuff, I use that to see if he helps me understand how Webpack works. And then I go back and forth between this, and I think that's going to be like helpful to make me understand what kind of graphs might be better to do. And at the same time that I do this stuff, I think I'm going to do offstream. I'm going to search for these keywords here and watch the course again. And then like off stream, I'm gonna go more on this other route of the fundamental stuff. And then on stream, I do this stuff on the Webpack. And then obviously I want to merge the two because a lot of the stuff that I want to build is going to be related to both of them. But it's very hard, and I'm not really sure like how long it's going to take. So yeah, I'm probably going to stream like 2 days from now or tomorrow. And I'm going to study Webpack and try to do this stuff. So